Let's say your company is moving into a new office. What do you need? Desks and chairs? Check. Laptops and monitors? Check. Snacks and drinks? Check. What's left? Oh, right, the internet. You've got to call a cable company and get some broadband installed. But you think to yourself, why just get one internet connection? They go down all the time. Why don't you just get two different lines installed from two different ISPs? That way, your employees will always have at least one connection to use, right? Plus, if a small number of users are using up all the bandwidth on one, everyone else can use the other. Well, that's a noble goal, but the implementation is a bit trickier than it may seem. If you want those two connections to run as totally separate networks, then you don't have much to worry about. But there's a good chance you'll actually want to join those connections together onto the same network. That way, your employees only have to connect to one signal, and the printers, scanners, and shared file servers only need to get added to one network. Seems like much less headache. But this is where the problems start. You see, combining signals into a single network isn't unusual, but most setups use a form of load balancing called PCC, per connection classifier. This is designed for maximizing bandwidth utilization and distributing traffic evenly across links. It's not designed for session persistence. So while your users who are browsing the web might not notice that their IP is changing mid session, your users who are on a VPN or a Zoom call or logged into a secure website most certainly will. So you're stuck. If you section off a single network and tell everyone to use it, you'll avoid the mid session switching issue, but you'll defeat the point of the second internet connection. If you use PCC load balancing, you'll get your traffic balanced between the networks, but your user sessions will break. What do you do? The authors of today's paper believe they have a solution. It's called policy based routing, PBR, and it works by explicitly directing different types of traffic over specific connections instead of distributing them randomly. In doing so, it preserves session stability while still using both links efficiently. On today's episode of Journal Club, we'll walk through the architecture of their system and see how it held up when they put it to the test. If you're already subscribed to our email newsletter, then you'll be getting this episode in text, audio, and video form delivered to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.